Chapter 4, 4.1, we're looking at combining functions graphically. So we're going to look at adding, subtracting, multiplying, and dividing two functions if all we're given is the graph of each function. So this is the only section where this idea comes out, and it is an important section. In our workbook, it is a math lab, but I've found that it is beneficial for most students to see some examples before the math lab. So here we go. Question number 1. We are given two graphs, f of x and g of x, and we are asked to add the two functions together. Now, right away, we need to take note of this notation that we have up here, which is a little bit strange looking. This notation that we're given up here is defined to mean that we will take the f of x function and we will add to it the g of x function. It's just notation. So there's no deeper meaning behind it. And if you look at it and say, oh, I'm just going to take this x and distribute it in, that's not what's happening. So it's not being distributed in, it's just a notation. So when you see this notation at the top here, f plus g of x, it means we're going to take the f of x function and we will add the g of x function to it. So here's what we can do. I'm going to use a different type of pen here. There we go, as I make some dots. So I'm going to look along some vertical lines here. So remember that f of x gives me y values for any given input of x value. Similarly, g of x gives me y values for any given value for x. So what we're saying is, for any one value of x, what do I get for f of x? What do I get for g of x? Add them together. So since we're looking at the same value for x, we are looking along vertical lines. So here I've drawn a vertical line, a dotted line, along the y-axis. So this vertical line represents all the y values when x is equal to 0. So here, x is equal to -1, -2, -3, -4, -5, -6, and this I think is where I'm going to start, because as I look at my two graphs, I can see that the black graph is crossing through a nice intersection point, so I can figure out the y value. Similarly, my reddish graph is crossing through a nice point here, so I can figure out the y value there. So when x is -6, my f of x function has a value of -5. So remember, that's the y value of this function. And the g of x function has a y value of +5. So if I add those two together, -5 plus +5, I get 0. So the sum of the two functions will give me a point right here. So now, how about I move this line along? And I'm going to look here. I don't get very nice y values for this x value. So I'm going to come here to where x is -4. So here I can get some nice y values. On my f of x function, f of -4 is equal to 0. G of -4 is equal to 4. 0 plus 4 is 4. So this point here will be on the sum of these two functions. And let's continue on. Oh, that does do that. Okay, let's drag this over. And again, I'm looking for some nice y values. Not so nice. There I have some nice y values. So my f of x function has a y value of 3. My g of x function has a y value of 3. 3 plus 3 is 6. Add them together, and I'll get this point up there. We continue moving along. So we'll drag this. Not nice y values. Here I have nice y values. My f of x function has a y value of 4. My g of x function has a y value of 2. 4 plus 2 gives me 6. So my graph will go through this point, and we'll continue moving to the right. So I'm just going to leave that line there, and I'm just going to do it a little more visually here. So here, not a nice y value, not nice, so I'm going to skip that one. Here I have a y value of 1, a y value of 3. 1 plus 3, 4. I add them together, and I get a point here. Not nice y. Oh, 0 plus 0. What does it give me? 0. Not so nice. Negative 1 plus negative 5 is negative 6. Gives me a point there. Negative 2, and I can't see down there. So these are all the points that I can draw. And as you look at this, it kind of looks parabolic. And in fact, it is. So if you were just to imagine adding these two functions together, what we're doing is we're adding a quadratic function and a linear function. When we add, we collect like terms. So still we'll have quadratic terms and we'll have linear terms in that quadratic function. So then I'll do my best to connect the dots. This will not be pretty because I'm drawing it. I drew it fairly roughly, but that's as good as I could get. So this is what the sum of f of x plus g of x looks like, or f plus g of x. They mean the same thing. There we go. That's question one, where we're adding two functions together. Question two, similar idea. Now we have fg of x. And so what we're going to be doing is we'll be multiplying the two functions together. So it will be similar to what we did above, but this time instead of adding the two y values, we're going to multiply them. So again, let me look here. I have a y value of negative 5, a y value of positive 5. Negative 5 times positive 5 gives me negative 25. Way off my grid, can't sketch it. Let's move along. Drawing the next one. When x is equal to negative 4. There we go. Well, now this one should work because I have a y value of 0, a y value of 4. 0 times 4 is 0. And so we'll have a point right here on that product function. Then as I continue along looking at other x values, here for this x value, my f of x has a value of 3. My g of x has a value of 3. 3 times 3 is 9. So I'm going to have a point up here when I multiply those two y values together. And let me continue without that vertical line. Here I'll have 2 times 4 gives me 8. So we'll have a point going through here. Next one, now I have a 3 times 1 gives me 3. So my graph goes through there. Here, 0 times 0 is 0. Here, negative 1 times negative 5 is a positive 5. So my graph is going to swoop up here. So now it's not looking parabolic, but it's going to have this wavy shape. And again, if you think of it, I have a linear function, which has the highest degree of x. I have a quadratic function. Highest degree is x squared. X times x squared, x cubed. So the result is going to be a cubic-shaped graph. And again, this will not be pretty, but hopefully you can draw better on paper where you can see what you're drawing. But this is more or less what your graph will look like. Yes, yours should look better than mine. Okay, so there we're multiplying two functions. And again, take note of the notation. Here, this f times g of x means f of x times g of x. Just a notation. On to the next example. So for the next one, we're going to divide f of x divided by g of x. So we haven't done a subtraction of two functions, but it's basically the same idea. But we want to do two divisions here because some different things can happen. So I'm not going to draw the vertical line now. I'm just going to have you kind of think along the graph with me to see what happens if I do f divided by g. So again, I'm going to just rewrite this as the f of x function divided by the g of x function. And actually, it would have been good if I had used some color coordination here. My f of x function is red, my g of x function is black. So that helps me when I'm thinking about it, because here I have colors, I can say, oh, red divided by black. Or dotted line. So in this case, I just drew the dotted line. So on a page where you don't have color, it's easier to distinguish. So I'm intending that this is actually a solid line. I just made it stand out by drawing it as a dotted line. All right, let's look at some values again. So I'm doing quadratic divided by linear. So here I have -5 for y divided by +5 gives me 1. 1? No, it gives me -1. Negative divided by positive gives me a negative. And there we go. A little slow, but it comes. I'm going to make this a little bit fatter so it's easier just to do a quick dot. Okay, now I'm going to come here. And now I have f of x is 0 divided by 4. 0 divided by 4 is 0. Come here. Y values are 3. 3 divided by 3 is 1. Here I'm doing f of x. So 4 divided by 2 is 2. Oh, it's looking kind of linear here. So let's just stop for a moment and think. If I do degree 2 divided by degree 1, oh, I would expect degree 1. I would expect to see a line. Here we'll have 3 divided by 1, which gives me 3. Here I have 0 divided by 0. And we know from chapter 2 that means I will have a point of discontinuity. So there's going to be a hole in my graph. Where that hole is, well, I could guess at this point, but I'm just going to wait and see what happens with the rest of my pattern here. So let me come over here. Again, I'm doing my quadratic divided by the linear. So I have -5 divided by -1 gives me +5. And that's the last point that I can draw. See, how big is my dot now? Not too big. Excellent. So as I look along here, I can see my pattern that my graph should go through this point, except this is going to be a hole in the graph. So I need to draw it as a circle. And then when I sketch my graph, this time I can just use a ruler, straight edge to draw, and that's what we'll end up with. So this linear function with a hole in it. That's question 3. On to question 4. Now, well, let's just look back here for a second. We did quadratic divided by linear, ended up looking linear with a hole. Okay, now here I have linear divided by quadratic. So this will be more like a rational function. And, well, they're both rational, but this one will have the asymptotes happening. So let me think about what's happening again. Grab my marker. I won't make it too big this time. And again, I'm doing g this time. So now I have +5 divided by -5 gives me a -1. So we have a point there. I come here. +4 divided by 0. If I have a constant divided by 0, that will give me a vertical asymptote. Remember, 0 over 0 was a point of discontinuity. Some number over 0 was a vertical asymptote. So here's my vertical asymptote for this function. And what's going to happen? Well, we'll get some more points and see what the pattern looks like. So we'll come here. Now again, I'm doing the linear divided by quadratic. So I have 3 divided by 3, which will be 1. So it's looking linear at this point if I just looked at those 2 points, but those aren't the only 2 points. I come here and I will get 2 divided by 4. Oh, well, that'll be a half. So I'll actually have a point here. And then I come up here and I'll do 1 divided by 3. Well, that's a third. So this is getting more approximating-ish than actually being precise. Here I have 0 divided by 0. So here again, I'm going to have a hole. Well, let's come over here, and I'm doing linear, which is -1, divided by -5 is positive 1/5. So I see that my graph is approaching a horizontal asymptote as I go to the right here, and on the left here, it's going to be doing the same thing. So it looks to me like my graph is going to curve and then go up like this. Let's just do an approximation over here. So suppose I did something like, I have this value, which is, pardon me, 3.5-ish divided by almost 2. So let's just pretend it was 4 divided by 2. Well, that would be 2. So I know it is going to keep getting bigger here. It's not quite 2 because that isn't a 4. So I'm going to be up here somewhere, and my graph is just going to continue curving up in that direction. Over here, I could do something similar. Let's pick this point. This is about 4.5 divided by about 2. Well, if I think 4 divided by -2 is about a -2. So again, my graph is going to curve down in this direction. So I get an idea for what's going to happen. And over here, I'll have a point of discontinuity. So I'll sketch my curve and then I'll leave a gap for that point of discontinuity. And there we go. So here, I didn't go through this point, but that wasn't a very precise one anyhow. I went through all these others where I could determine the value with a little more precision. So there's the basic idea for looking at graphs and then sketching the result that you get when you add, subtract, multiply, or divide. One more idea before we finish this lesson. We're going to look at domains and ranges, well, domains in particular, as we combine two functions together. Finding the domain for these functions should be relatively easy. Here, as I look at this one, let's go with f of x first. The smallest value that f of x can have looks like it's about here, -1, -2, -3, -4. So that'll be the smallest value there, and then goes up to +5. So -4 to +5, that will be my domain for the f of x function. And then similarly for the range, here I should say the domain of the g of x function, I'm going from -5 to +3. So there we go, -5 to +3. Again, I could have used other notations. I just picked this one because I felt like it. Okay, if you're not told how to write domains, it is your choice, and I'll have to be flexible. So now, as we're looking at what is the domain when I subtract the two functions? Well, when we're going to subtract two functions, if I look over here where x is -5, my g of x function is defined, but the f of x function isn't defined. Can I subtract two things if one of them doesn't exist? And the answer is no. So it's not going to exist here. I have to come up to here to where both functions exist. And so this will be the starting point for the domain when I'm going to subtract these two functions. And as I go to the right, I have both functions, both functions, both functions, both, and then only one function. Only f of x exists up here where the x value is 4. So if I want to add, subtract, multiply, or divide, I'm going to be limited to those values where both functions exist. So here I'll say my x value is greater than or equal to, the smallest number here would be a -4, and the largest number there would be a +3. So this will be my domain here when I'm going to subtract these two functions. Not too bad. You just have to look, where do both functions exist? For number 7, it's a little bit trickier because since I'm dividing, there are now going to be some additional restrictions because I can't divide by 0. So I'm going to take a look here and see, well, g of x, that's this curvy function. It's dividing by the f of x function. Well, f of x doesn't exist, but then it's 0. I can't divide by 0. So I can't use -4 or -3 or -2. I can't use any of those values up to here. Now, I'm left kind of guessing what's happening there. Not exactly sure, so I'm going to say, well, to be on the safe side, I'll say that my f of x function is equal to 0. So I can't do g of x divided by f of x. I'm putting an open circle here. But now I have some values here that I can divide. But then once I pass this point again, my f of x function is defined, but g of x isn't. And so when I think about my domain will be in between these values. So as far as both functions are defined, and then in this direction, as far as they're defined, but also the denominator is not 0. So when it comes to writing my domain now, and my pen is responding slowly. There we go, it's finally connected. My smallest value is a -2, but I can't reach that value. So -2 is less than, not equal to, x, which is less than or equal to +3. So this would be my domain for the division of these two functions. And that gives you an introduction to finding domains and restrictions when we are performing operations with two functions. And so far, we're just doing it by graphing. So you have some time to work through practice questions in the math lab. Alrighty, that's it. Took more time than I expected, but good to get that foundation down.